So we will go through whatever question you want. I have to write a little slower, softer, and I can't bend my wrist like one. My husband thinks it's in the red. Yeah, so overuse of my wrist. So I'm gonna go be a technical, but he also has tendonitis, so he has so I'm not bend my wrist. We'll go. On the first page, what questions do we have? Here. 3. If you need or would like a ruler, there are some in the top tray. You can grab that. So reminder, with our solving by graphing, we are graphing the line and seeing if you can intersect, don't intersect, graph them over each other, whatever. So for these two, I'm going to do these in 2 separate colors. I would advise doing that as well, like on your quiz, on the review. 2 different writing utensils, 2 different colors. There are color pencils in the color part as well. So for the first one, start at your y-intercept of +2. One finger. And then our slope is the number in front of x. It's -1. It's invisible. You don't see it. But that means I can go down 1 and do the right one. Thinking back to how we draw a slope. And do that as many times as possible. Down 1, right 1. Then we can also go the opposite way, up 1 and left 1 as many times as possible. Draw a line through all of those points. Not working. Okay. That line should look something like that. And then we're going to do the same thing with the other one. Plot your y-intercept at that 1. Slope is the same. So down 1, right 1 as many times as possible, up 1, left 1 as many times as possible, draw in those points. And draw in that line, connect other points, make your line. Do those intersect somewhere? No. So if they don't intersect, what type of solution is that? They are parallel lines, what type of solution is that? So NS or the 0 of the line directly or. So if they intersect, that would be your solution. If they don't intersect at all, no solution. If they are the same exact line, they graph on top of each other, infinitely many solutions. Other questions on this one? Number 1. Right, so if we graph this first one, what's our y-intercept? 3. Start at +3. Our slope is also 3 over 1. So in this case, I can't go up 3 to the right 1. It's not a 6. But I can go down 3 to the left 1 as many times as possible. Draw that line. And then do the next one. What's your y-intercept of the second one? -4. So put a point at -4 on the y-axis. Slope is negative, so we can go up 1, left, up 1, left 2, as many times as possible. Down 1, right 2, just 1. Draw that line. Do those intersect? Yes, where? -2, -3. Write that as an order here. And that would be your answer. Yes. 4. I will say that all of the other ones are gonna have a solution, but for sake of time, let's come back to 4. Work on the others and then we'll come back. But all of the other ones will be graphed to have ones. Go to the back. So these 4 are solving by substitution. There are different ways to view them. One, we have to look for an equation that is solved for x or y, and then go from there. We would need to see, we'll go over and over. Alright, so let's actually start with 5. These are both solved for y. So then you have a choice. You can take the bottom equation and substitute it into the first, or you can take the top equation and substitute it into the second. Doesn't matter, because it's going to be this equals this on one way or the other. Whichever one you choose to substitute into the other, they're going to end up equaling each other. In this case only, because they're both set into one. There's not a whole lot of space on this, so if you need more paper, or if you grab more scrap paper. For this one, we would solve it like a normal equation. Get all your variables on one side, all your functions on the other. So I can move this forward. And then get rid of the 1 by subtracting it to the other side. And then divide everything by -6. So that x is what? -1. But remember, that's part of it. You still have to go back and find y. How you do that is up to you. You have 2 equations, both solved for y. Put this in for one of your x's, doesn't matter which one. So let's say we did the first one. So y equals -4 times -1 plus 1. And then simplify. You can do this all in your calculator at once, do it by pieces, so you. This will become a +4, so that our y value is 5. We write this as an ordered pair, -1, 5. So if they're solved for the same variables, set them equal to each other. Questions on that one before we do. Now, in 8, there aren't any variables solved for itself. So we can look and find one that will be easy to solve. Either of these, because it has a coefficient of 1 or -1, either of those would work. Do we want to solve for x or for y? For So if we're solving this one for x, we have to get rid of y by adding it to the other side. We have x equals -12 plus y. Now we have an equation that's solved for the variable. Now we can take that equation and put it back in the first one where x. So we're going to rewrite that first equation. So it would be 6, and then instead of x, we're going to put -12 plus y in parentheses, plus 4y equals -22. Then we have an equation. We're going to solve it, distribute the 6. We have -72 plus 6y plus 4y equals -22. Combine your y's together to get 10y. Get rid of 72 by adding it to the other side. And divide both sides by 10. The y's value is what? 5. Just like the last one, we have to go back and find x. So we're going to take this value, put it into our x equation. We have choices. This one of the original and the one we solved. Since this one is already solved for x, I would take them out. We have x equals -12 plus 5. What's our x value? So we would write that word pair x and then y -7, 5. Six and 7 are similar, except this would be like we already have this in an equation like how we saw for one of the when we started this. So that's what you would do for 6 and 7. Start the substitute. Questions on 8. Let's look in 2.3. 3.3 is only the first time. What questions did you want to go over in that section? And we can do that one. Let's do the one. Right. So remember with elimination, you're trying to eliminate one of the variables. Look and see if you have common coefficients. If you have common coefficients, you're looking at how can I eliminate these? Could I add these together or subtract them together to eliminate? So these are the same. Would I add or subtract them to become 0? And then we're subtracting everything. So 3x minus 3x would give us 0. -3y minus -y, be careful because of the negatives. That would really be -3y plus y, so -2. Same thing with your constants, -y minus -3 would be -3 plus 3, -6. Divide both sides by -2. So that your y value is 3. Then this part is the same as substitution. Take this, put it in one of your equations to go back to 5x. Let's say I put it in the second one. So 3x minus 3 equals -3. And then we're solving that one by adding 3 to both sides. And dividing. If you get 0 as part of your order pair, that's okay. So our order pair for this one will be 0, 3. Remember that at any point while you're solving by substitution or elimination, you can take this point, put it back in your x and y, and see that it equals the same thing on both sides. As a way to check this. Questions on 10 before we do 12? Okay. 12, we don't have common quotients. Make that. But first, do we want to eliminate the x's or the y's? Doesn't matter. Okay, so if we're eliminating the y's, you can think of a number that these both go into and think of what those go into as we multiply it, or just take numbers and multiply it. So multiply this one by 9 and this one by 7. So both equations are going to change. All the numbers are going to change to 54x plus 63y equals someone multiply 9 and 14. 126. And then 49x plus 63y equals multiply 13 and 7. Great. Do we have a common coefficient now? Something where the numbers are the same? Yes. Our y. To eliminate these, could we add them or subtract them? All right, so 54 minus 49 would be 5. This is just going to become like 0. 126 minus 117. It's going to be a fraction. I don't remember if that was supposed to be a fraction. Something there is wrong. This is supposed to be 91. And then that would be 35. Okay. And then divide both sides by 5. So that x equals 7. Then you have choices. You have 4 choices to do your x back into any of these equations to find your y value. Let's say I put it back into the first one. So this would give me 42 plus 7y equals 14. Get rid of 42. And divide both sides by itself. So that y would equal 4, -4. And that would be your point. The methods to solving your word problems are the same methods as what we just did, graphing, substitution, elimination. So I can help you set up any of those, but we're not going to solve them. We have time to set up one problem before lunch. Pick one. 15. Right, so Mary and Carlos are selling flower bulbs for a school fundraiser. Customers can buy bags of one flower bulb and packages of I don't know. Mary sold 5 bags of wind flower bulbs and 14 bags of bulbs for a total of $330. Carlos sold 5 bags of wind flower bulbs and 10 packages of purchase bulbs for a total of $250. Find the cost of each 1 bag of wind flower and 1 bag of bulbs. So important things, we'll find out in what's important here.
Forward.
Okay. Okay.
5 back full.
Right, so we will set that up when we get back from lunch. You guys can grab your phones.
Yeah.
Okay, so you have enough time. Let's set this up. We can set up 15 and then just work triggers with. And then come back. So this one had 6 different pieces of information that was important. Because it has 6 different numbers, the 5, the 14, the 330, the 5, the 10, the 250, all of those numbers get used. As a reminder, you need 2 variables to describe what you're looking for. The cost of 1 wind flower bulb and the cost of 1 purpose bulb. What you choose to call those are up to you. W is C, X is Y. It doesn't matter. Be specific when you define your variables, the cost of whatever it is. So define your 2 variables, whatever variables you choose, be specific, what are you looking for, cost of, amount of, X, Y, Z, of whatever. If nothing else, if it gives you totals, you know those are going to be what these equal. All of these are going to be set up basically the same way in that AX plus BY equals C format. So your totals will be your C. You have 5 and 14. You have your variables. You're going to put that together to equal 330. So 5W plus 14C. That would be one of your equations. And then 5 and 10 with your variables. 5W plus 10C equals the 250. Then you would choose one of your methods of solving. This one has the same coefficient, So I would do this one by elimination. I'm not gonna do that for sake of time, but that's what you would do. At the end, when you get your final answers for W and for C, make sure you're putting your labels. So for this one, it would be dollars. Questions on how we set that one up? You have a question? Right, 13. Flying with the wind, a plane went 184 kilometers per hour. Flying into the same wind, the plane only went 168 kilometers per hour. Find the speed of the plane and still air and the speed of the wind. So important thing. With the wind, 184. Into the same wind, 168. And then we're looking for the speed of both. So if we were to set this up for two variables, we can call it W and T like we did before. For speed of each. We have our totals, 184 and 168. Remember that with the wind, the plane is being pushed by the wind, so the wind is adding. If it's flying into that same wind, the wind is no longer helping it, it's now being subtracted from it. If you get a problem like this, make sure you're not subtracting the speed of the plane, but the speed of the wind. And then you have different options. You could choose to graph by solving. You could solve this by substitution or elimination. And then at the end, your labels would be your kilometers per hour. Questions on how we set that one up? Okay, so all of your plane, boat, current, river, all of those will be set up very similarly. If you have 6 numbers, 2 and then a total, 2 and then a total, you're using all of those. If you have 4 numbers, 2 of them are going to be your total. 2 of them go with one of the totals. The other one will just be variables. Do we have any other last minute questions before you guys have questions? If you have a watch, go ahead and take that off, put it with your phone. If you didn't grab a calculator, make sure you have that. You can work together, use your notes.